Um, okay. Good morning, class. Today we're gonna revise paper 4, physics, alternative to practical, June 2016. I have shared the file with you guys, and hopefully you print it out and together with the marking scheme. All right, as usual, this paper contains 4 questions. Let's start with question number 1. For question number 1, it's an experiment or student investigates the oscillations. Now, the first thing that you need to take note is the word oscillation. The oscillation itself is actually like a pendulum where it swings from one point back and forth. Okay, but it depends on the position or how it oscillates. The student starts by supporting one end. So this, you have to read this question properly. The word one end of a heavy rod using a stand, boss, and a clamp. It shows how he assembled the apparatus. Now this is from a side view. Okay. Explain why it is not best way to assemble one end. If we draw, even for question number 2, they ask us to draw or sketch the diagram. Sketch a better way of assembling this apparatus. Okay, so if I draw this one into a different diagram, it actually looks like this. From a front view, so this is the boss, and then the rod will be from this side. So this is the rod because it says from one end. So as you know, if you clamp the rod from one end, you will notice that this rod will be unstable. Okay, it become unstable. Just wait for a while. Okay, it's become unstable. So that's why explain why this is not the best way to assemble one stand, the boss, and a clamp to support a heavy rod, because it is unstable. In the space to the right of the figure 11, sketch a better way to assembling this apparatus. So basically, on the second diagram, probably you need 2 retort stand. Okay, by having 2 retort stand, one is one side for the retort stand, one will be on the other side with a clamp here, and then you can put your rod in the middle, so it will be balanced, or it will be stable. Now it will be shown on this part B. The 2 clamps are used to support the rod horizontally, about 60 centimeter above the bench, as shown in figure 1.2. Assembling this apparatus. Okay, I think I made it kind of bit. Now, what they meant here is they need to have only one clamp. The best way, probably, it will be um, like this. You have this base, and then you have on the horizontal, and then the rod, you can place it in the middle, then it will be balanced. So I'm sure this is how you clamp the rod to be stable. Okay, for question number 2 or part B, the two clamps are used. Now we have two clamps are used to support the rod horizontally, right? It's 6 centimeter above the bench. The students are given a meter rule and two sets of set square to check the rod is horizontal. Explain how he can tell the rod is horizontal. Now, last time when we did the practical, I did remind you guys how do we check if the rod is horizontal. All you need to do is to take your ruler, the meter rule, measure one side of the rod. You need to measure one side of the rod using your ruler, meter rule, and then one side to the of the end of the rod, and then make sure you have your set square to check if the ruler is vertical. Okay, if you want to use two set square, you just put on both sides just to make sure. Now by measuring both end, you have to do it individually or one by one. Measure one end and then after that you measure the other end. If the two height both side of the clamp or both side of the rod is equal, so technically the rod is horizontal. Okay, you can check on the marking scheme. Both side have equal height. Okay, for part C, the student suspend the meter rule from the rod of equal length. Half meter rule is placed on the bench, and a meter rule above 0 end of half meter rule. Describe how the student can check that the NA of the meter rule is exactly above 0 of the half meter rule. So this is the half meter rule. How do you check they are they are above it? It's very easy actually. All you need to do is to take your ruler, place it here. Okay, and then after that, all you need to do is just take your set square to check. Now that will be very easy to check if the ruler half meter rule is above the 0 of the meter ruler. Okay, you can check on the marking scheme. This is how we check if it's aligned. Part 2, the meter rule is moved to the left, and A is above 10 centimeter mark on the half meter rule, and then it is released as the meter rules swing. So here the word swing is the part where you need to understand it is the oscillation. Okay, the amplitude of the swing decreases. So if we do practically, we able to imagine how it swing, but in this case, since it is alternative to practical, we need to imagine how the things will work. So by pulling the meter rule to the right and then once you let it go, and it will swing to the side and back again to the right and back again to the left, and it will continue the oscillation until it's stopped. So describe, sorry, one more time. So the student count the number of swing until A is no longer passes the 5 centimeter mark on the half meter rule. So he will continue repeat it several times, and his results are shown below. N is the number of swing, okay, given two significant figure by calculating the average. So NAV is the average by 53 plus 55 plus 52 plus 51 plus 53, and you divide it by 5 and you will get an answer. Make sure you have two significant figure, okay. Now, as you can see here, for question number 1 you will have 53. All right, you will have 53. The answer is 53. D. A student is given one square piece of a card, and he attached the center of the card to the NA of the meter rule with a small piece of blue tack. Now, in this case, hopefully you understand the question. The meter rule, since it's swing, if you place a piece of card here of this one end, it will affect the swing, especially you will have more friction, especially air friction. Once it's swing, so the air will against this paper. There is an air friction. The air friction, in this case, the air friction will be proportional to the size or the area of the paper, of the card, okay. The bigger the card, the more air friction it will generate, or so it will oppose the motion of the swing. Now, since the length of the paper is, let me check again, the length is 19 centimeter at first. So if we draw the piece of card, first it will be 19, and then the number of oscillation that you can get is only 3 oscillation. After you reduce to 15, and you will get more number of oscillation, and after you reduce again up to until 3, which is even smaller piece of card, you will have more number of oscillation. All right, the 0 part here is the one where you don't have to put the card, the one that we calculate. And then we got a 53 by calculating the average. Complete the table, and then you have to plot the graph of L centimeter on the y-axis. Make sure you do the y-axis with L centimeter, L, and then the number of oscillation will be on the x-axis. And then you have to start with 0, 0. And this graph we will have to draw smooth curve. So if we look through the graph here, so we have to darken the paper, the x-axis, and then the y-axis. Wow, the paper is too okay. All right, and the x-axis will be, let me refer again one more time, the x-axis will be the number of oscillation. So the x-axis will be the number NAV, and then I forgot to highlight this part, and the length will be on the y-axis, length for centimeter. Now it's all about to have a proper scale. Let's do the x-axis first. The x-axis minimum is 3, the highest is 53. So normally we will target the largest number at the end of the graph. Either we can take 60 or you can take 55 for the furthest, the end of the graph. For example, let me show you. So this is the end of the x-axis. Either you can put here as 60 or 55. Now we have to check again one more time. Here if we take the scale as 10, 20, 30, 40, and then 50, and obviously here will be 60. Now remember, the significant figure of the x-axis must be the same as like the on the table of the graph. Now the problem is the y-axis here. Now the y-axis here, you have a minimum of 0 and the maximum is 19. So basically at the end, I'll try to put as 20 at the end of the graph. So from 0 to 20. Alright, now it seems like my graph, the line is not exactly on the graph, the side of the graph. Let me rub this one out. Okay, let me redraw a little bit. Okay, next will be the y-axis. Okay, no. Sorry about that, but okay. All right. So, like I said, from 0 to 20, so we need to have the maximum here as 20. Let me check again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we get every one big square as 2. This one will be 2, 2. Yeah, sorry. Here will be 2, 2. It's supposed to be 2.0. Am I correct? Yeah, 2.0. We have to have 2.0 centimeter, 2, and then 4, and then 6, 8, and then 10, 12, 14, 16, 18, and then 20. All right. Now all we need to do is to plot the graph. All right, let me take a picture on this one. Okay. The first value need to be plot will be from 30 to 53. I'll do this 0 to 53. 0 to 53, it's here. And then 3 to 35, 35. Okay, that will be here. 722 will be 7 will be here. 722. Oh no, 22. Okay, so 7 will be here, and then we have 11, 12, 11, 12 will be here, 15 and 6, 15 here, and 6 will be 5, 6, 15, 6 is here, and last will be 19 and 3, which is 19 and 3. Okay, it should be here. All right. Three and 6, and then okay, so the graph will look like this. All you need to do is to draw a smooth curve. So I'll try my best to draw a smooth curve here. So class, try your best to, now since the curve is over here, so your palm will be here, right? So that is the center of the circle. You can draw with the smooth curve by using your twisting your palm in this particular direction. So sorry about my curve, my hand, because I'm drawing on the screen of the laptop. So try your best to draw the smooth curve. Okay, so that's my smooth curve, and then after that, the graph shows L decrease as the number of the oscillation increase. The two quantity x and y are inversely proportional if they obey the equation where k is a constant. By taking two pairs of value from the graph, show that the NAV is not inversely proportional to the L. By taking two pairs of value on the graph, it's not inversely proportional. By taking two pair, okay, so I'm kind of confused with this question. Let us check the marking scheme. So the n times the number of since one pair of value of the OR table to correct value of xy calculated and not equal. Okay, now I get it what they want here. Now if we take two values, two pair of set of data, okay, for example 7 x and y, 722. So the x-axis is the number of oscillation, and the y-axis, okay, this is x, this is y. So if we have 319, and then the other one is 35 and 3. Okay, now if we substitute this value here, if x is 3 times by 19, that will give you 57. So the 57 is actually the constant k that refers to the first coordinate from the first point. The second point here is if you have x times y, 35 times 3, it will give you 105, which is the value of the k. So the both k is not equal. So hence NAV is not inversely proportional to L. So that is how you explain they are not inversely proportional. And number 4, suggest why the students start at 19 and then reduce L rather than start at 3. Now the piece of paper here, you start at 19 and then you reduce to 3 centimeter. Why it is more appropriate, you start with the bigger piece of paper and then reduce to 3 rather than from 3 to 9. The reason why here is, of course, you start with the bigger paper, and then if you want to reduce it, all you need to do is to cut it the side of the paper. Okay, and then after you finish the second reading, and then you cut again the smaller and smaller. If you start with a small piece of paper, it is impossible for you guys to add or make it bigger because it's already been cut. So the reason here is, just refer to the marking scheme. Less cut will be used, or use one piece of a cut. Just wait for one. Alright, next question. For question number 2, a student investigate the path of ray of light through a triangular prism. On page 7 shows a triangular prism placed on the center of a sheet of paper. So this is the paper, triangular prism. All you need to do, you have to mark label P, mark and label P the midpoint of the side AB of the prism. And then you have to draw normal to the prism P, and then you have to draw the ray of incident ray with the angle of incidence of 40 through point P. So now this is the piece of paper, this is AB. All you need to do, so you have to draw at the center of AB. So basically you have to measure the length AB and then you have to find the midpoint. Once you get the midpoint, you have to draw the normal. So the normal here is from here, as you remember from my previous lesson, make sure you draw the normal with a certain amount, reasonable amount, the length of the normal. So there's the normal, and then you have to label as P, and then after that you have to draw angle of incidence. Okay, so the angle of incidence here, you can either from here or the other side here. Okay, so now let's enlarge the diagram. So one, you have to draw 40 degree. Sorry about that. Can you please use your protractor to draw the angle of incidence. Okay, now it's 60, so I need to have 40. 40 should be all right. So if you prefer blue color, I can go so this is my ray of light with the angle of incident 40°. Alright, let's go back to the question. If you follow all the instruction, if you draw it properly, normal, and then you mark and label P, and then you draw the line represent the angle of incident 40°, you get 3 marks altogether. And then after that, describe how the student can use the ray of light to find the path of the ray through the prism. So this is the ray box, and of course it will produce a ray of light, and then this ray of light will be shined through the prism from here. So the box will be placed here, and then it will show you shine a light, and once it enters the prism, and it will continue, and if we do it properly, it will show this path. And as you know, as light enters the prism, which is denser, the light will refract towards the normal. So this is the ray of light, and after that I have to draw again the normal, and then it will refracted away from the normal. So refracted away from the normal. So this way. So this is the diagram, but in practical, it is when we do practical, we have to use a pin. So that pin need to be plotted at a certain point. First, remember the ray of light, you have to place two pin, pin 1 and P2. Make sure the length between them is 5 centimeter minimum. And then inside the glass block, it is impossible for you to put the pin because above it is a glass prism. But the light will shine continue to the other side. So here you have to place P3, the pin number 3 and pin number 4. And of course, the length between them is also 5 centimeter. So once you remove the glass block, so the ray of light can be traced, and then you can continue the light. All right, so that you have to explain on this part. So describe how the student can use the narrow ray of light to find the path of the ray through the prism. Oh, by the way, we have to label here. This is what we call the emergent ray. So this one is incident ray, and of course inside here will be the refracted ray, just for your information. Now here for the 4 marks, let's refer to the marking scheme. For question number 2 part B, of course they use the ray box, and then you have to use the cross or dot to mark the incident ray. Okay, and then after that we have cross, and then to mark the incident ray, we did that one, and then mark the emergent ray with the pins, or we prefer use the word cross, put cross, and then the emergent ray drawn through the cross, and then you have to join the cross from the emergent ray, and then the last one is to join inside the glass block. Okay, which is ray drawn from the prism to join the incident and the emergent ray, and this one will be the actually the refracted ray in the middle here. Okay, so you can put it over here, the marking, the answer, it's 4 marks. Huh? All right, let's move on to the next question. Question number 3. Question number 3 is quite easy. To investigate the force, measure the force using a set of bathroom scale. And of course, you did this one before by standing on the scale, and then by looking at the scale here. What is the weight of the person? Make sure you know this is 500. This one is 600. So every one division here will represent as how much? It should be, make sure you know, it should be 20. Is it 20? 1, 2, let me check again. 1, 2, 3, 4. 120, 140, 160, 180. Yes, it is every 20. So the answer here will be 540. Okay, now since here we don't have the unit, make sure you put the proper unit, Newton. Explain why student needs to stand still on the scale. Of course, you need to stand still because you want to have the reading to be stable or constant. Okay, you can check the marking scheme here what they want. Definitely moving change a reading so that it will be steady, or not, it will be does not change, or the needle to be stable. Explain why it is more accurate if the student take the reading from directly above the scale. And in this case, we did learn about the error of human error. One of them is what we call the parallax error. Just to avoid, you want to avoid the parallax error. And even here, the marking scheme did mention about parallax error. Number part B. As two students use the scale to measure the maximum friction force between the bench and the heavy box. This one is kind of unique. I never done this one before. He pushes the scale with both hands, and the other student notes take the reading of the scale when the box just to start to move. Oh yeah, is it? Oh yeah, this one. Explain why it is important that the student pushing the box increases the force slowly. In this case, you want to have the force to be, let me check the marking scheme, because if you at the beginning to get the largest reading, the reading just before it changes or start to move, little time to take the reading. Okay, but if based on my experience, when we do this practically, at the beginning, you have to overcome the inertia. So once you start to push the object, you will get slowly the force will be becoming constant. So that value as a constant force when you push the box. Okay, so the force F here, you need to be constant because you want to get as the friction against it. The friction will be on this opposite side. That will be the friction. All right. So the answer here, yeah, we have to follow the marking scheme to get the largest, to get the largest reading. Reading just before it changes or start to move, little time to take reading. Kind of not agree with the answer. It's kind of weird. Yeah, basically you just get to get the largest reading, huh? And number two reason, suggest a reason why student place the box near the edge of the bench. And this one also kind of a bit weird for me. So that the student able to reach the box, or easy for the student to push the box. Yeah, that's the answer. So he can push it. If you place at the end of the bench, the student can easily push or reach the box. Kind of common sense answer. And last one for number four. It's about a cylindrical tube where you put two circular piece of paper, or they call it the reel. And this is actually a reel. Anti-large reel was used to hold ribbon. Okay, and then in the middle there that we have a cylindrical. Uh, the cylindrical cylinder has a diameter of 3 centimeter. So here we have a diameter here, 3 centimeter. The two students use different method to find diameter of the cylinder. So basically you're using two methods. The first method is by using this apparatus to find the diameter. So basically the cylinder, you need to place it over here, and then you can find the diameter. Okay. So this thing need to be adjusted by using the screw, and then you will get proper reading. Describe how the student measure diameter is by adjusting the screw once the large, we call this one caliper or jaw, exactly at the side of the tube. Okay, that will be giving you the diameter. By looking at the marking scheme, it just says that the apparatus just fit across the diameter. So anyway, but my answer is also correct. And then number part B, this one is kind of a bit difficult. Other student measure the diameter using only the following apparatus. You need to have a meter rule, a pencil, a blue tack, 1 meter of the thin thread. Describe clearly how you can find accurate value of the diameter. Now, if you want to find the diameter of a cylinder, if you remember, I'm not sure whether we did this experiment. So if you have this cylinder, all you need to do is to take the thread, one piece of thread, long thread, a very long thread, and then once you have this long thread, take this thread, you wind on the cylinder, you wind it. So one, 2, 3, 4, 5, 6, 7, 8, 9, 10. But remember, you have to put this thread close together. Okay, now you can put as 10 wind. Okay, 10 wind. Okay, and then all you need to do is take the reading from this point to this point. All right, so since you have that length, then you can cut it and take the piece of thread, you measure the length, and then you divide it by, so diameter is equal to, so the length divided by the 10 number of wind, so that you can get the diameter in centimeter, which is very, very accurate. All right. So if you look at the marking scheme, wind thread around the cylinder, you can get from the number of time from 3 or 10 number of wind, and then measure the length of the string, and then the diameter can be, you can get the diameter L divided by, oh yeah, I forgot about that part, you have to divide it by the number of pi. Yes. Oh yeah, you have to divide it by n pi, okay, which is the circumference. Let me redo this one again. So mathematically, if you do the mathematical, okay, if you do the mathematical here, sorry about this diagram. So you have 10 circumference, okay. One circumference, if you want to calculate circumference, the formula is C is equal to 2 pi r, okay, all right. And the r and the 2 is actually the diameter, so it's d and then the pi. So d is the diameter, c is the circumference, all right. since you have since you have 10 number of circumference, all right, so the total length will be the diameter, sorry about that. So diameter is equal to c, the total length, which is the L divided by the pi, and then the 10, is it the number of the circumference. Let me check again. Yeah, the number of pi. Yeah. So I think that's all. Kind of difficult on that part. So that's the end of the paper. So hopefully you guys revise this paper. All right. Thank you.